This video is going to focus on how you write a recursive rule for a geometric sequence. A recursive rule is essentially asking you, what do you do to the previous term to get the next term? Some people say, what do you redo every time? What reoccurs every time? What repeats every time in order to create your recursive rule? So the notation we use for a recursive rule is slightly different. We still use the T of n notation that should be familiar from your explicit rules, but we also use T of n plus 1, because if T of n is the nth term, then T of n plus 1 is just the term after that, so the next term, one more after it. So if you had in front of you this formula, which was T of n plus 1 equals T of n plus 7, that means in order to get T of 10, that is the same thing as doing T of 9 plus 7. So you're taking the ninth term and you're adding 7 to it. And if you wanted to do T of 11, then you'd have to find the T of 10th term plus 7 as well. And so that's what a recursive rule does. It essentially says, what are you doing every time? You'd be adding 7 to the term before it to get the next. Now that's nice and all, and it's pretty simple, straightforward, especially as you take a look at your generators. However, what it lacks is an understanding of what exactly the values are. I know what I'm doing. I know what I'm doing here to the previous term. I'm always adding 7, but I don't actually know what the initial term is or what any of the terms are if this is all that's written. That's why for every recursive rule, you will also have another secondary statement that will tell you where to start. Like in this scenario, let's say T of 1 was equal to 15. If that's the case, then if I'm writing out my sequence, I know that it's going to start with 15, and then I'm going to add 7 to it. So this is term 1. So to get term 2, I would add 7 to term 1. So that would be a 22. And then I would add 7 to that, which would be 29, so on and so forth, where you'd be continually adding 7 every single time. And so you'll see that with all recursive rules, you need to have this statement, which tells you what you're doing, but also some statement as to where you start or a specific value. T of 1 is nice because it's where you're starting. There's nothing that says it has to be. Somebody else could have said that T of 3 was equal to 29, and that would have given us the same pattern because it would be the third term is 29. You'd work forward with adding 7, and you work backward with subtracting 7. So let's look at some different examples. These examples are the same examples that were in the video for the explicit rule for geometric sequences from a list. So let's just turn these into a recursive rule. As you can see, we still have our first term, which is 120. Our second term is 60 for this first example on the left. And then our third term is 30. And so what we notice is that what we're doing each time is that we are dividing by 2, but we want to write that as multiplying by 1/2 every single time in order to get the next term. And so in order to find the next term, that's what you'd write. N plus 1 is the next term. What you're doing is you're multiplying 1/2 by T of n, right? So that's all it is. Instead of adding, like you saw in the previous example, this one we're multiplying. So 1/2 times T of n. And that would be our rule because that's what we're doing every single time. So that should go down where our rule is sitting, but we have to remember that we aren't finished yet because we need a secondary statement. Right now I know what the pattern is to my sequence. I know that I'm always multiplying the previous term by 1/2 to get the next, but I don't have in my rule stated where you're starting or any other piece of information. So I like to use T of 1 because that's the very first term in the sequence. All you have to do is write what T of 1 is. T of 1 equals 120. Now I know where I start. I know what I do to the previous term to get the next, and you can write from there. So as we look at our other example, same idea. 4 is term 1, 12 is term 2, 36 is term 3, and so on and so forth. What we're doing each time here is we're multiplying by 3 every single time. So we're going to multiply by 3 every single time to get the next term. So that means that T of n plus 1 would be equal to 3 times T of n. And so just one more time to try to solidify that, if I wanted to find T of 3, that is apparently, according to this formula, 3 times T of 2, right? Because that's just one more here than the n that was in here, which is what this formula says. So I do 3 times T of 2. In order to do this, you'd have to know what T of 2 is. And you have to work yourself backwards, which is why you also need to work all the way back to T of 1. So write that secondary statement there, where it says t of 1 is equal to 4. Now I know where I start, I know what I do to my next term, or to get my next term, and that would be your recursive rule.